All right, so we're to our final section of Unit 2, and so this kind of goes in a little bit of a different direction, but factoring will still be a key tool that will be used here, and so it just kind of reinforces it. But our next unit, Unit 3, will kind of pick up from this section. Okay, so this is almost kind of like going to be a starting point for our next unit. So, all right, so looking here, basically we're going to get into fractions, and that's what we're looking at right here, simplifying rational expressions. So rational is just a fancy word for fraction. And so first we're going to identify restricted values of these rational expressions. And so we've covered this before, that we don't want to divide by 0, right? So can't divide by 0. So what we're going to do is we're going to go ahead and take the denominator, what's right here, can't divide by 0, and basically set it equal to 0 and solve it. And then that will give you your restricted value. So in this example right here, 3 is your restricted value. So we'd actually say x cannot equal 3 right there. So that's our restricted value. X cannot equal 3. All right, so then our next example, same idea. Take the denominator, which in this case is a quadratic, and we'll set that equal to 0. And so we want to solve this, and the best way to solve this is by factoring. So we'll go ahead and do the A&M method. So this should be x plus 10, x plus 1. And so you can see that the solution to this is negative 10 and negative 1, or basically you want to say x cannot equal, and it'll probably look like this in your homework, where they'll already have that part of it for you, and then you just fill in the box right here. And so it doesn't matter which one goes first. So negative 10 comma negative 1. So that's the restricted values. If I plug this into this equation, what will happen is, if I, like for example, if I plug in negative 10, I'll get negative 11 on top, but the problem is on bottom I'll have a 0. Can't divide by 0. Okay, so that's about all we're going to look at as far as restricted values, but this will come up in other sections, especially in college algebra. So this is something you don't want to just kind of forget about. So just remember, can't divide by 0, and so we just started out by restricting those values that would cause that to occur. All right, so now moving forward, we're going to focus on simplifying rational expressions, and a lot of time factoring will be key to helping us do that, okay? So when simplifying rational expressions, factor the numerator and denominator, and then cancel out any common factors. So I'm going to start with one that should look kind of familiar to you guys right here. This is a review problem. You've already done problems like this, just to kind of review and try to remember how these things work. And so I'm going to do it a little different than we did in when I originally showed you this. Originally, you just kind of you did the the quotient rule with your exponents, but I'm going to do this one a little bit differently. So what I want you to see here is, let's see, 30, isn't that the same thing as 6 times 5, right? And the reason I'm doing that is because I'm going to cancel out the 6's in a moment, okay? And then let's see, I had x to the 4th over x to the 7th. So I'm going to put x to the 4th right here. Now what I'm going to do with x to the 7th is I'm going to break that up into x to the 4th times x to the 3rd, right? Because that's the same thing as x to the 7th. I just broke them apart into a product. But you would add those back together if you wanted to multiply those. And what I'm trying to do right now is get these common factors that I can cancel out, like the 6's, and then I'm going to cancel out the x to the 4th in a minute. And then let's see, my last part, let's see the y. I got y to the 5th on top and y to the 2nd on bottom. So kind of like what I did with the x's, I'm going to break this into y to the 2nd times y to the 3rd, which same thing as y to the 5th, just kind of factored it, broke it into two factors. And then I have y to the 2nd on bottom, right? Okay. So what I'm going to do next is I'm going to cancel out those common factors. So what I want to point out is, notice that it's all multiplication on top and bottom, okay? So that's kind of key when you want to start canceling stuff out, okay? And so let's see, I'm going to go ahead and cancel out the 6's. Oops, let me do that in a different color. Let's see. So the 6's cancel out. Now what happens is they really turn into 1's, but that that's kind of doesn't really matter. You can kind of forget about those, okay? And same thing with the x to the power of 4. Those cancel out. They basically turn into 1s, but once again, we can kind of ignore them at the end. And then the y to the power of 2, those cancel out. So see, what you're left with on top is 1 times 5 times 1 times 1. So those 1s don't really play much of a role. And then you also have y to the power of 3. So I'm going to end up with 5y to the power of 3 on top. And then on bottom, let's see, 1 times x to the third times 1. So I'm just left with x to the third on bottom. And that's my answer. Okay, most of the problems we're about to do aren't going to look like this. They're different, but the concept is the same as far as how you cancel. And so that's why I wanted to do a review problem. And like I said, I approached this a little bit differently than we did in our I believe this was actually in our very first section of Unit 2. Okay, moving forward, the way we're going to look at these is you want to look at the top and bottom and see what can be factored. The most common mistake students will make is this. They'll say, oh, okay, well, let's see. The 9s cancel out, 6x and 3x, reduces down to a 2, and that is completely incorrect. It's completely understandable why you would think that, but that's not what's taking place, okay? The problem here is that you have subtraction, and addition here. And so that complicates the situation. If you look at my review example, it was all multiplication. And so that's what I need to do up here. I need to break this all into multiplication, and that's where factoring comes in, okay? So, see, the reason I can't just cancel out the plus 9 and the minus 9 is because that plus 9 is also dividing into the 3x. This is dividing into everything on top, okay? And so that's why it's a little bit more complicated. It's not, to be honest, it's not going to be super hard, but your gut instincts are going to be wrong about trying to cancel things out. What you got to do first is factor, factor, factor. So on top, I can factor out a 3. So I'm going to go ahead and do that. And so that would leave me with an x minus 3, right? 3 times x minus 3. So the key thing is, look, I broke it into multiplication, okay? Yes, there's a minus, but it's contained within the parentheses, okay? Which is a good thing. Now on bottom, I'm going to do the A and M method, and you'll see that this should break up into x minus 3 and another x minus 3. Okay, and once again, this is broken up into multiplication. Yes, there's minuses, but they're contained within the parentheses. So the last step is, what can I cancel out? And so if you cancel anything out, it has to be identical. Well, I can cancel out this x minus 3 with either one of these. It doesn't matter. Just pick one. I'll cancel out with that one. And so what that leaves me with on top is 3 over x minus 3. Now, once again, you might have that thought, oh, I'll cancel out the 3's right here. But it doesn't work that way, because you still have this minus x, or I'm sorry, you have the x there with it, x minus 3. And so these actually come together, okay? These, you don't have to put parentheses around it, but I typically do that to remind myself it's, it's together. They're a team together. The x minus 3, they go together, okay? If it's going to cancel out, they're going to have to be together when they do it, okay? So that is our answer right there for that first one. Now, if they were to ask you about restricted values, the restricted value would be that x cannot equal 3. All right, so just to let you know, I paused the video for a second and I double checked. They won't ask you for the restricted value. I've seen some books that do that, but on your homework, they won't ask you for that. So you can just ignore that. Okay, so let's move on to our next example. So looking at number 9, so once again, just put parentheses around it and just start thinking factor. I got a factor. So on top, let's see, this is going to factor into x. Let's see, what is that going to be? Minus 6, x minus 6. And on bottom, I can factor out a 4, and that'll leave me with x minus 6. And then we can cancel out one of the x minus 6 on top with the one on bottom. And that'll leave us with x minus 6 all over 4. You can leave it like that. Do not try to cancel the 4 with the 6, because the 4 is also dividing into the x, and so that wouldn't be fair. So you remember, these go together as a team. They stay as a team. All right, let's try another one. All right, so on number 11, let's see, I got to do the A&M method on top and bottom. So let's see, on top, let's see, multiply, give me negative 18, add up to positive 7. I believe that's going to be 9 and negative 2. So y plus 9 and y minus 2. And then on bottom, let's see, I believe that's going to be negative 2 and negative 1, right? So let's see, y minus 2 and y minus 1. And so now we look to see if we have any identical factors, and we do. The y minus 2 and the y minus 2. They don't have to be directly above each other. Just one has to be on the top and one has to be on the bottom. So those cancel out, and that leaves me with y plus 9 over y minus 1. Once again, don't try to do anything funny here, okay? So you can't cancel out the y's. You can leave it like this. That's your answer. That's fine. If you want to be safe, you can put parentheses around it to remind you that those are teams, okay? All right, got one more on this slide, and then I only have one more slide to go. So let's see. On top right here, we'll do the A&M method. It looks like we have a perfect square trinomial. They're going to both be plus 6, x plus 6. And then on bottom, we have the difference of two squares. So that should be x plus 6 and an x minus 6. Now remember, they have to be the exact same. So I do have a pair, both x plus 6. So I go ahead and knock those out. So I'm left with an x plus 6 over an x minus 6. Once again, don't try to do anything with the 6's or the x's. There's your answer. That's it. All right. All right. So next, let's see. Now I'm multiplying two of these together. You know, it's not really going to change all that much. What I like to do is put each part in parentheses, okay? Kind of help me keep it organized. And then just try to factor each one individually. So the first one, the x minus 2, there's not really anything I can do about that. Now, by the way, when I multiply these together, I can just go ahead and multiply the tops together. Not a big deal. I mean, don't actually, don't FOIL or anything like that. You don't want to do that. But on the second numerator, I can factor out 2, so I'll go ahead and do that. And then that will factor that into an x plus 3. Okay, on bottom, let's see, I can factor out a 3 to start with there, and that'll leave me with an x plus 3. And then times, I can pull out a 2 on bottom, and that'll leave me with an x minus 2. Now we'll kind of go through and see what can cancel out. So remember, they don't have to be directly above each other, but one has to be on top and one has to be on bottom. So I have an x minus 2, x minus 2. I'll cross those out. Let's see, I'll try to color code this a little bit. And then let's see, I have a 2 factor and a 2 factor. Those cancel out, okay? And then I have an x plus 3 and an x plus 3. So all I'm left with is a 3 on bottom. Now be careful, because not really. The common mistake students think is, oh, the answer is just 3, right? Well, remember, all these really reduce down to 1s, okay? So I'm actually left with a 1 on top, 1 times 1 times 1, and then on bottom, 3 times 1 times 1 times 1. So it's going to be 1/3. Very important, 1/3, okay? So be careful. It's a common mistake. Students will just put the answer as 3. Okay, looking at 17, same deal going on here, just we're going to factor all these, okay? So let's see, on top, start with, I have the difference of two squares, so let's see, that'll be x plus 3, x minus 3, and then I can factor out an x on that second numerator, and that will leave me with x minus 3 also. So I got 2 of those, okay? And then let's see what we have going on bottom. So right here I have an x squared. If you notice, see, I have an x right here to the 1 power. What I might want to do with that x squared is just break it into x times x. So I can cancel one of them out in just a second. And then on the trinomial, I'll go ahead and do the A&M method. So multiply to give me negative 12, but add up to positive 1. Thinking, let's see, 4 and negative 3. So x plus 4 and x minus 3. And now we'll go through and see what can cancel out. So let's see, it doesn't matter which x minus 3 you pick. I'll just pick this one, okay? So it cancels out with that one right there. And then let's see, I have this x right here. I can cancel it out with that x. So I'll just kind of cross it out, okay? And I think that's it. So on top, I'm left with x plus 3 times x minus 3 all over x times x plus 4. And that's what I have going on right there. Okay, the last couple we're going to look at, looks like we're going to do division. And I believe, let's see, we've done this trick before, the keep, change, flip. And so I basically have that right here. So if you have A over B divided by C over D, you keep the first fraction, change it from division to multiplication, and then flip the second fraction, and then go ahead and complete the problem that way. So these problems really aren't going to be any different from the ones we just did up here. You just have one little extra step in the beginning. And so what we'll do here is we'll keep the first one. So we'll put that as x plus 1 over 3. And then we're going to change it to multiplication. And then the 7 will go on top. And I'm going to flip this down below. And as I do that, I'm going to go ahead and factor it now. So I can factor out a 3 right there. And then I'm going to have an x plus 1 on bottom. Okay, so I factored out the 3, and then I have x plus 1. Now, if you want to start canceling now, you can. It's not really that big of a deal. So, because all these are on top and all these are on bottom, I'll go ahead and rewrite it as 1. But if you felt comfortable doing it now, that would be fine. But let's see, I'll go ahead and write it over one fraction in case you're unsure. So 3 times 3 times x plus 1. And so we'll go ahead and cancel out the x plus 1s. So we're left with 7 and 3 times 3 on bottom. None of those can be reduced. So we're going to leave it as 7 over 3 times 3, which is 9. So that's simplified into 7 over 9. All right, let's see. Yeah, I only got 2 left. So looking at 27, this is going to have to do a little bit more factoring than that previous one. Okay, so we're going to keep this first one, but I'm going to go ahead. If you notice, between 4x squared and plus 10, I can pull out a 2. So I'm going to pull out a 2, and that'll leave me with, oops, my eraser isn't working the way it normally does. All right, so that'll leave me with 2x squared plus 5 all over x minus 3. Then we're going to change it to multiplication. And now we're going to flip it so that x squared minus 9 is going to flip into x plus 3, x minus 3, all over. And then on bottom, we can pull out a, looks like a 3. And so that would leave us with 2x squared plus 5. Okay, and to save a little bit of space, I'll probably start to cancel out now. Okay, so you can just kind of extend that and put the multiplication there. So that looks like a division sign. It's not division, so hopefully you're not thinking that. So what I'm going to do here is I can cancel out the 2x squared plus 5 and the 2x squared plus 5. And then I can cancel out this x minus 3 with this x minus 3 here. Okay. And what that leaves us with on top is the 2 times x plus 3. And on bottom, all we have left is that 3, because these would basically reduce down to 1s, right? So 1 times 3 times 1, so I'm left with a 3 on bottom. And then you know, you don't try to cancel out with that plus 3. So that would be my end result right there. Okay, last one. This one's got quite a bit going on here, but you know, if you break them into little steps, it's really not too bad. So we'll factor the difference of 2 squares right here. X plus 5, x minus 5. And then on bottom, I can factor out a 2, so I'll go ahead and do that. That'll leave me with an x minus 1. Okay, then we're going to change it to multiplication, and we got to flip it. So we'll look at this one first because that one will go on top. Multiply, give me negative 5, add up to 4, I believe. Let's see, that'll be an x plus 5 and an x minus 1. Yeah, I think that looks good. Okay, and then we'll do the A&M here, and this will flip down below, so it's going to be x plus 5, x plus 5. Okay, so now you kind of look across the board, and you can cancel out with anything on top with anything on bottom. So let's see, I'm going to cancel out this x plus 5 with this x plus 5. Okay, then let's see, I can cancel out the x minus 5. Oh, no, I can't actually. Sorry. Oop, undo that. Let's see, I got another x plus 5. There we go. I can cancel that out with that one. And then last but not least, I've got that x minus 1. I'll cancel out with the x minus 1 right there. And so what that leaves us, all that just simplifies down into an x minus 5 over 2. Okay? And there you go. That's our answer. Okay, so that's going to be the end of our second unit, but our third unit, as I mentioned at the beginning, will basically pick up where we're leaving off right here. To be honest, the reason I included this in Unit 2 is because, it's more or less of a factoring exercise. It's just a lot of factoring still, right? Factoring and then reducing, right? But when we start Unit 3, we'll kind of continue on with these fractions, and then there's some other topics that we'll hit on, but this will be where we'll pick up.